In sums like these, we generally use the number of days taken to finish the work to represent it in the form of the amount of work done in one day. So if M is the number of days a man takes to finish the work, then 1 upon M will be the work done by him in one day. Similarly, if B is the number of days a boy takes to finish the work, then 1 upon B will be the work done by the boy in one day. So in this sum it is given that a man and a boy complete the work together in 24 days. That means in one day they will be finishing 1 by 24 part of the work, right? So this 1 by 24 part of the work involves one day of the man's work as well as one day of the boy's work. So it will be 1 upon M plus 1 upon B. Okay, this becomes our first equation. Then what they have said is, in the second case, if the man works alone for the last 6 days, then the total time required to finish the work is 26 days. That means for the first 20 days, there's that is the man and the boy work together. In those 20 days, they will be finishing 20 by 24 part of the work, which is equal to 5 upon 6 part of the work in the first 20 days. That means in the last 6 days, when the man is working alone, he is completing the remaining 1 by 6th part of the work, right? So man takes 6 days to finish 1 by 6th of the work. Therefore, so the man will need a total of 36 days to finish the work, right? So M is equal to 36. So we'll use this value of M in this equation to find the value of B. So it will be 1 upon 24 is equal to 1 upon 36 plus 1 upon B, which gives us 1 upon B is equal to 1 upon 24 minus 1 upon 36. Using 72 as the LCM for these two numbers, we get 1 upon B is equal to 3 minus 2 upon 72, which is equal to 1 upon 72. Therefore, B is equal to 72 days. That means the boy needs 72 days to finish the entire work alone. In the second question, it is mentioned that A takes 25 days to finish a particular work. For the same work, B takes 20 days. Okay, and these two people work together for 5 days. So in 5 days, they will be finishing, A will finish 5 by 25 part of the work, while B will finish 5 by 20 part of the work. So together, they will be finishing 1 upon 5 plus 1 upon 4, which is equal to 9 by 20 part of the work in those 5 days. So the remaining work is now supposed to be finished by B alone. So we need to find the remaining amount of work. Therefore, remaining work is equal to 1 minus 9 by 20, which comes to 11 by 20. Now B alone takes 20 days to finish the entire work. So this is 11 by 20th part of the work. B will need 11 days to finish the job, remaining job. 11 days to finish it. In the third question, we are supposed to find the distribution of rupees 1400 into three people. First is man 1, man 2, and a boy. They, depending on the proportion of work that each one of them is doing. They are given that M1 takes 7 days, M2 takes 8 days to finish the work individually, but we don't know the number of days that the boy takes, but they have given that the three together finish the work in 3 days. Okay, so that means we have 1 upon M1 plus 1 upon M2 plus 1 upon B is equal to 1 upon 3. Since we know the numbers for M1 and M2, we can use that to find the value of B. So therefore 1 upon B is equal to 1 upon 3 minus 1 upon M1. M1 is 7 and 1 upon M2, which is 8. Okay, simplifying this, what we get is 1 upon 3 minus 15 upon 56. So, which comes to, we get an LCM of 168 for these. So, 168. It becomes 56 minus 45, which is 11 upon 168. So 1 upon B is equal to 11 upon 168. That means 11 upon 168 is the amount of work that the boy is doing in one day. Since each one of them is working for 3 days, so it will be 3 upon 7 in case of M1, 3 upon 8 in case of M2, and 3 into 11 upon 168, which gives us 11 upon 56 in case of the boy. So this is the amount of work that each one of those is doing in those 3 days. We need to find the proportion of work that each one of them is doing. So we'll first need to bring them to a common denominator. So we get the common denominators as 56. So it will be 24 upon 56. This will be 21 upon 56, and this is 11 upon 56. The numerators add up to 56. 24 plus 21 plus 11 is also 56. So the total work is now complete. So the ratio of distribution will be 24x for M1, 21x for M2, and 11x for the boy. So to get total amount that we are supposed to divide amongst the three is rupees 1400. So therefore the addition of these three is 1400. Therefore 56x is equal to 1400. Therefore we get the value of x as 1400 divided by 56, which comes to 25. Okay, so therefore M1 will get 24x, which is equal to rupees 600. M2 will get 21x, which is equal to rupees 525, and the boy will get rupees 11x, which is equal to rupees 275. So this is our required answer. In this question, a certain input effort is resulting in a certain output of work done. So the input is in terms of number of men employed, the number of days that they work, and the number of hours per day that they work. And the output is in terms of number of units of work done. The question says that X number of men work for X number of days for x hours per day result into a work of x units of work done. And we are asked to find what will be the work done if y number of men work for y number of days for y hours per day. So in this case, the number of men x to get translated into y, it will have to be multiplied by y upon x. Okay, so x multiplied by y upon x will give a result of y number of men. Same will be the case with number of days, where x will be multiplied by y upon x to give y, and same will be the case with number of hours per day. Okay, so we get y number of men multiplied by y number of days and multiplied by y number of hours per day. The result will also be multiplied by similar fashion, but in this case it is y cube upon x cube that it will get multiplied by. So it will be y cube upon x cube. So x multiplied by y cube upon x cube will give us a result of y cube upon x square, number of units of work done. So this will be our required answer.